Well, hey, algebra, here is the do now for today. There's an answer to a box multiplication problem there. See if you can figure out the original problem into the green and blue bubbles. All right. So we're going to look at the greatest common factor for those two numbers inside the box. -1 would be the greatest common factor, so that goes on the outside. And then the -1 would need to multiply by what number? That's this x to get the answer of -1x. And this -1x would have to multiply by what number? That'll be +3 to get this answer of -3. So we take our answer and put it into the left side over here, our factored answer, -1, and then parentheses, x plus 3. So those two things in the green bubbles go together inside the parentheses. So that same problem has been written down below without the box, no area model. If the question just asks you to factor -1x minus 3, it would mean exactly the same thing. You could visualize the box model. You could actually write a box model out, whatever would work for you. That is the more typical way we're going to see it written in an algebra context. So today we're looking at factoring, and the learning target is you'll be able to factor a polynomial. So you got to remember, factoring is what that means is it's a process where we take something, a polynomial, and write it as a multiplication problem. So we'll take something that is originally not a multiplication problem and write it as a multiplication problem by undergoing this process of factoring. So here's the polynomial. I've got 4 terms separated by plus signs. So a polynomial is a collection of different types of numbers, different variables, different exponents, and each of those terms in green has been separated by either a plus or a minus sign. These are all pluses. It could have been minus signs. It would have done the same thing. And so you can see there are 4 terms, all combined with addition. So the directions ask us to factor. This obviously is not a multiplication problem, it's addition. So we're going to need to rewrite this into a multiplication format. The way we do that is I'm going to take these 4 terms and put them inside this multiplication box. I'm going to pretend like that was the answer, and we need to find the original multiplication problem. So we always want to make sure that the term that has the highest exponent is in the upper left corner, and the term which has the lowest exponent, or in this case, it doesn't even have a variable or exponent at all, the +3, it needs to go in the bottom right. Okay, now we're going to look just at that top row. We're going to find the greatest common factor for this top row. So I'm looking across there. What do they both have in common? Both of them have a 2 as a multiple, and they both contain an x. So 2x would be my greatest common factor. And now I need this mystery number up here. That red 2x would need to be multiplied by what mystery number to get that green answer of 2x squared? Well, we'd have to multiply it by an x. That's how we get that exponent of 2. X to the power of 2 means x multiplied by itself. So I need a red x multiplied by another x, the blue one, to get the power of 2. Next mystery number, that red 2x multiplied by what would give us the answer of +6x. So I'd need to multiply by +3. And now we're going to go down the other side. So I need this mystery number over here in the red circle. So the blue x multiplied by what is going to give me that green answer of +x. And it would be times +1. This last part is just a double checking. That red +1, if I multiply it by this blue +3, does that actually multiply to give me this bottom box, +3? It does. Awesome. So now that I have all of those numbers filled in, I'm going to write my final answer, the factored form. It's that original polynomial, except changed so that it is written as a multiplication problem, which would still be equivalent to the same thing, but is totally written as multiplication. So I'm going to take these 2 red terms, the 2x plus 1, I'm going to put those together inside one set of parentheses. And the 2 blue terms, the x and the +3, those are going to go together inside a different set of parentheses. And now I have written this as a multiplication problem. I get the red parentheses multiplied by the blue set of parentheses. If I actually multiply those together using the multiplication box, I'm going to end up back at this original polynomial that I was given. Those are the green things that I put inside the box. So I know that is the answer I'd get if I did the multiplication. All right, well, let's try one more just to make sure we got this under wraps. So I'm going to put the original polynomial into this box. I got 3x squared minus 12x plus 2x minus 8. Let's look at the top row. Greatest common factor. Those are both multiples of 3. They both contain an x. Mystery number on the top. That red 3x times what is going to give me 3x to the power of 2. Well, I'm going to need another x to get x multiplied by itself. That's where that green x squared came from. Next mystery number, the red 3x multiplied by what will give me negative 12x. So I need a negative number, so I get that negative answer. 3 times 4 is going to give me that 12. And then let's go down the other side. So that blue x on the top multiplied by what is going to give me this green answer of positive 2x? Well, I'd have to multiply by positive 2. Then it's kind of a formality, but we do need to double check just to make sure we haven't made a mistake anyplace. So the red positive 2 multiplied by that blue negative 4. If I multiply them, do I actually get negative 8? Yes. Yay. All right. So now I can write my final answer as a multiplication. Here is my factored form. I'm going to put those two red terms together inside one set of parentheses, so 3x plus 2, and then the two blue ones together, x minus 4. It does not make any difference. Sometimes people ask this. It doesn't make any difference which of those you write down first, the red set of parentheses first or the blue set. It doesn't make any difference. You can write either one. I just wrote the red ones because I could see them still. But you could write the blue ones first. It doesn't make any difference. It still means the same thing, equally correct.